Hey everyone, welcome to this month's UJUG meeting. We're set to go live. Well, I guess we're already live, but we're set to start everything in about 10 minutes. So I just wanted to get everyone ready. Looks like we've got about 18 people here. I wanted to let everyone be aware of some of the abilities that we have here on Crowdcast. There is a poll that's down there in the bottom. Just kind of nothing serious this month. Just something to do. And then there's also chat. Please be courteous in the chat. If we need to disable chat, we will do that as well. But as long as everything's good to go, then we can do that. If you have questions, there's also an Ask a Question button down at the bottom as well, and those will be upvoted. I will leave that up to Todd as far as when he wants to take those, and we can go from there, or we can do them at the end, either way. I also have the option of bringing people online live. If you want to share your face cam with people, we can do that. If you're interested in doing that, just let us know as a comment for the question, and we can do that as well. Can you hear us, Todd? Maybe not. All right, sounds like at least one person can hear me, so I guess we're good there. Todd might just be quiet. All right, very good. We'll see when people start filtering in. So I can see Todd, but he can't hear me.
Someone else is talking. I can't hear them.
All right, so we've got Greg here, Wayne, Mike. Sounds like everyone can hear me, except for maybe Todd, unfortunately. Everyone else is mute, unless I bring people up so that they can share and talk and whatnot. And from my end, it looks like Todd might have just dropped. We'll see if he comes back in. So since this is our first time doing this virtually, everyone's going to have to kind of roll with the punches, and we'll see how things go. All right, there's Todd. How does virtual pizza work? That is a very interesting question, Mike. We will get to that. Can you hear me now, Todd?
Yes, I can. Can you hear me?
All right, there we go. Yes, I hear you as well.
I don't know why you can't see me, but
that's because I am sharing my screen right now.
Fair enough.
I'm taking up all the real estate. All right, so there's a question there. Yep, Todd's down there as a thumbnail in the bottom left. How do we choose Crowdcast? Simply the Jakarta EE group had a Crowdcast account that they were willing to let jugs use, and I took a look at it. Seemed like it was decent. And then I realized that it was all a single account, and it was kind of first come, first served. So then I decided, well, it's not overly expensive, so I'll just go purchase a year's worth, and we'll go from there, see how it works. So the question that we had about virtual pizza from Mike, since we've got just a little bit of time left. What we're doing this time, instead of shipping pizza out to everyone, we are actually going to be making a donation to the Utah Food Bank for the typical cost of pizza is what we'll be doing to help those that are not able to feed themselves at this point in time. So we will be doing that this month. Hey, it looks like we're starting to get people filtering in with about 4 minutes until we go live. Question about muting or whatnot. No, you do not need to mute or anything unless we bring you up live. Then you are already all muted. It's kind of like a webinar in that vein. You're all viewers until you get brought up. Kind of like we bring you up on the stage and hand you a mic is essentially what it becomes. So since we've got some more people coming in, I will mention this again. We'll keep chat up unless things get out of hand. And then if that happens, we'll disable chat. If you have questions, please use the Ask a Question button down in the bottom of the browser. And if you see a question that's similar, then feel free to upvote that. And I will leave it to Todd as to when he wants to take those. And we'll mark those as answered as they come up. And we'll go ahead and do that. There's also a poll down there as well. Nothing too serious. Just kind of lighten the mood a little bit. And I know we've got people from various places. At least I saw people that were coming up. We had, of course, people from the Utah area. We've got people from other areas in the US. And we also had some international people that signed up as well. So that should be interesting. All right, with just a couple of minutes to go, I think. Ari, are you there?
Yes, I am.
Excellent, very good. All right, so let's do this. Alrighty, so I'd like everyone to meet Ari over here. Ari is with JFrog. If you want to introduce yourself real quick, and we'll jump on your slide in just a minute.
Okay, great. Do you have it there, or do you need me to pull it up?
If you want to pull it up, that would be fine.
Okay.
And we'll introduce you real quick. So Ari is with JFrog. JFrog is one of our newest sponsors. And they are taking some of the, about a minute tonight to say hi to everyone.
Actually, you know what? The slide, because of the way it's set up, the slide is not working.
Cool. All right, try it now.
Okay, let's see. Yep.
Fernando, no, you do not need to mute.
Okay, great. I hope everyone can see the slide. Thanks again, Jason. My name is Ari Waller, and I'm the Meetup Event Manager at JFrog. And we're real excited to be a sponsor and part of the Utah Java community in 2020. For those of you who don't know, JFrog has been building community software since 2006, starting with our flagship product, Artifactory OSS, which many of you may be familiar with. Our software objective really is to empower Java developers to code secure and high quality applications that flow into production really with zero downtime. So we've been doing it for years. We have end-to-end solutions for that. I have two quick community initiatives I'd love to share with you, referring to the slide. If you know of anyone right now who is joining the technical battle against COVID-19, our Frog Care program has been set up to allow these projects to use free enterprise DevOps tools that they can access for this effort. So we're real proud to be part of that with our world-class software, and would love it if you could recommend it to anyone, because it's there for them to help fight this battle. Also, to spread a little bit of quarantine cheer for anybody, for our meetup and virtual conference communities, our April sweepstakes is for 3 Nintendo Switch Lites with Animal Crossing. These have been sold out if you've tried to find them. It's been real tough. But at the end of the month, we're going to do a drawing for 3. And if you look at the QR code below, it'll take you to the entry form. You'll also see the bit.ly, and I'll add that to the chat box as well. But again, Jason and team, thank you so much for allowing us to be part of your community, and excited to hear the talk tonight.
Great. Thank you so much. Glad to have you as a sponsor. And I want to go back and share this one. All right. So just to get things underway real quick, since we're starting, we'll do just a few announcements here and there, and then we'll dig into the meat of the meeting with Todd, talking about Kotlin, doing some introduction, and hopefully a little bit more than just an introduction, but we'll see how that goes. Again, sponsors that we've got here, if any of the sponsors are here watching, feel free to virtually raise your hand in chat. Let us know where you're there. So, of course, we just heard from JFrog. They're one of our newest sponsors. And then you can see the rest of the sponsors on the screen as well. Upcoming schedule that we've got going on. Next month, we have Venkat. Again, this will be a virtual one, and he will be doing a comparison and contrast with Angular, React, and Vue. So 3 of the top leading front-end frameworks available right now. He will be letting us know about those and doing a comparison and contrast. In June, we have Tim Berglund, who will be speaking probably about something about Kafka, being that that's what he does for a living. I don't have an abstract from him just yet. And then in May, we are still looking to find our speaker in May. If anyone has any suggestions that they would like to let us know, feel free, and we will go from there. The door prize entry, being that we're all kind of at home right now and many people have lost jobs and whatnot, so we're looking to see if your company is still hiring and which positions are open. Hopefully we can take that information and disseminate it back out into the community and help some people out which are otherwise in a little bit of a predicament right now. Pretty sure most, if not all of us, are able to work from home. And hopefully that's all working well for you all. All you need to do is email board@ujug.org. You'll be entered into the door prize drawing, and we'll get that information out. So speaking of the door prizes, what we've got for us tonight, we are only doing the digital prizes this month. So we've got 2 JetBrains licenses, and then also the Agile Learner subscription as well. That is for a year of Venkat's subscription, which is all good. So without any further ado, I will turn the time over to Todd.
Cool. Can everybody hear me okay?
You do have a little bit of an echo, but yes.
Okay, I'm sorry about that. Well, thank you for having me. I'm laying my slides up here, and we'll do that. I'm on one window. I'm a minimalist guy, so we'll I'll try to flip back and forth for questions as I can, but we'll see how that works. Let's get this in here. Sorry, should trying to present and show this at the same time. So. Having trouble getting it to share my screen here. Jason, do you know what I need to do to get this to show to presenter? Do I need to? Oh, here we go. Never mind.
Oh, there you go. There's a suggestion here, Todd, about turning down speakers, although you have a headset in, so I'm not sure if that's going to help. But we are getting echo on our end.
No, I'm sorry. Is that any better?
Nope.
Let me see if I can turn off my microphone somehow. Sorry about that, everybody.
Oh, that could be. All right. Well, if I'm the only one that is having echo, then I won't worry about it.
Okay.
That would be kind of interesting.
That'd be fun.
How would you like to do this, Todd? Do you want the split screen slides and your camera, or just the slides?
I'm not much to look at, but I'll it's up to you. How about dealer's choice? If you get sick of looking at me, you can go to the slides and I won't be offended. Otherwise, I'll aim at the green dot when I'm talking, and we'll see how that works.
All right, very good. Well, let's see what happens.
Cool. Can you see the front screen, the head of my slide deck here? Should say Introduction to Kotlin.
Yep.
Cool. Okay, cool. Well, as it says, it's an introduction to Kotlin. Before I start, I just want to say thank you again to Utah Jug for having me out. I was super excited to come to Utah. I've never been there, and I was really looking forward to it. And then the world fell apart. So I'm just glad that we can do this virtually. I've never done this one virtually before, so as you can see with the fiddling around a little bit, it's a learning experience for everybody. But I'm glad to be here to teach you about one of my favorite languages, which is Kotlin. So what's in a name before we get started? This picture here is Kronstadt Bay. Kronstadt Bay to the east has St. Petersburg, Russia, and that's the town where the office from JetBrains is that originated the Kotlin project. So the work started there, and when they were working on their new language nearly 10 years ago now, they wanted to name it after an island, kind of like Java is named after an island if you think about it. They wanted an island that's close to home, so they picked Kotlin Island, which has historically been the gateway to Kronstadt Bay. It's protected St. Petersburg from invasion by sea for centuries. So that's why Kotlin has the name Kotlin. It's actually also the name of a ketchup manufacturer in Poland. So some people think it was named after that, but it was named after Kotlin Island. So let's talk about what we're going to talk about. We're going to talk about what is Kotlin. At first, I'll give a brief overview of that. One question I like to ask when I'm using a new technology is, am I alone? I know it's trendy to say herd immunity now, but I like to have some herd immunity when I use something. I don't like to be the only one on my team doing something or picking something that's so esoteric that nobody will use it. We'll go through the syntax and features. There may be questions on that, and that's totally cool, but I'm going to try to ask you to save them to the end, and I've got my IDE open and ready to go. So if there are questions about, hey, what would you do if so-and-so, or can you go through that a little slower or something, I can just go to the IDE and I can show you an example of that. We'll go through a summary, and then we'll do, like I said, questions and probably answers at the end. So who am I? My name is Todd Ginsberg. I've just moved to Raleigh, North Carolina from Chicago. It was about 70 degrees here today and snowing in Chicago, so I think that was a pretty sweet move on my part. And I'm a principal developer at a company called NetSpend. They're owned by another company called Global Payments, which actually has an office in Salt Lake City, I believe. We're a payments company in Austin, Texas, and we love Java and Kotlin. If you're thinking about relocating to Austin, come talk to us. One more thing, I really love Java. I've been using Java for 25 years now, since the very beginning. So if I mention something about Java that maybe is not so flattering, it's from a place of love. It's not from hate. Similarly, if I mention Groovy or Scala or any other language really, as a comparison, it's really just as a comparison. I'm not doing it to denigrate any other languages. So what is Kotlin? Kotlin is a statically typed language developed by JetBrains. JetBrains are the company that put out IDEA, IntelliJ IDEA. a lot of other great tooling and IDEs. And it's released under the Apache 2 license, so you can go and you can contribute to this language. You can provide fixes. You can download the source code and build it yourself. Less likely to get into an argument with JetBrains over whether it's right to implement an API or not when it's implemented as an Apache 2 license. And while I'll be focusing on the Java-y kind of aspects of Kotlin today, it is designed to be a general purpose language. And what I mean by that is it targets either JVM 6 or 8 bytecode now, and I think there's a plan to do one of the newer bytecodes to take advantage of some of the newer things that have more recently come along. But you can also target JavaScript backend, and you can target any number of native platforms with Kotlin. For the last 2 Kotlin conferences, for example, the conference app has had an Android app, an iOS app, a web app, and a backend server, and the entire code base was Kotlin. So when I say Kotlin is a general purpose language, it's really meant to be usable on any platform. But by and large, people use it on the JVM or equivalents. You can use it on Android. That's why you can write the same code for all of those platforms and compile it down to whatever you like. So if I show you something, it works it'll work on any of those platforms. Its major features, as I said, it is 100% interoperable with Java. All of the great jars. There's, one of Java's biggest strengths, in my opinion, is the availability of libraries. Dozens and dozens of years, 24 years of library making has led us to, get some a great ecosystem around Java, and we don't have to throw that away by using Kotlin. All of those libraries, anything you're using now, you can just pull that right in and use it without any change at all. Anything that you would pull out of Artifactory or anything that you might have at work or at home, you can just use. And the language itself is designed to avoid entire classes of defects, and we'll get into what I mean by that. But I want you to remember that for when we go through it. Okay. The other thing I want you to remember is that lots of small improvements add up. So you'll see something I'll mention, hey, this is different in Kotlin, or this is better in Kotlin, or this is easier in Kotlin. It might be a small thing, but again, these are like a lot of small things in general, and it adds up to a really beautiful language, in my opinion. And as a consequence of that, it takes a lot less code to accomplish the same thing in Java. I was one of those people who have used Java for a really long time, and people say, "Oh, Java is really verbose," and I'm like, "What are you talking about? It's not that verbose. I mean, you just you mentally get used to the ceremony involved, and you don't see it or register it as complication. But when you come at it from another language, which is decidedly less verbose, you say, "Oh, now I see what you mean by that." And I find it when I read Kotlin, it's less mental acuity, mental gymnastics in order to figure out what somebody's intent was. The major feature you'll hear about Kotlin is null safety. If you don't think that null pointers are a problem in our industry, go up to GitHub and look. And I counted this morning, it was 199,000 issues on GitHub. Those are issues where people are complaining about null pointer exceptions. And that's just on GitHub. That's just the people who took the time to complain about something. So, I've checked more than my fair share of null pointer exception code into production. It's disturbingly easy to do so, even with the best of intent. And no matter how good you think you are as a developer, it's really easy to let those things slip by. On Stack Overflow, there's a question called, what is a null pointer exception and how do I fix it? There are 15,650 duplicate to that question. There's a really neat tool that Stack Overflow has that lets you do queries on questions, and you can write a query to say how many duplicates are there of this one question. So that's 15,650 people coming into our industry, usually at the start of a semester, and asking this question. It's a confusing concept. Null is a confusing concept to people. And so Kotlin goes out of its way to be null safe. And we'll see what I mean by that later. I'll go through that. Now, when I show you these features, you might say, hey, Kotlin ripped that off from Groovy, or Kotlin ripped that off from Scala, or some other language that I'm not mentioning. And they probably did.
If I can
That's okay.
inject real quick,
Sure.
Todd, I don't know what you did, but your sound sounds a lot better now. So whatever it is that you did, just keep doing it.
Touched the microphone. I touched my cable. Maybe my cable's super sensitive.
Ah,
I'm
much
glad.
better
I'm
now.
glad it's working out.
No.
Cool.
You no longer sound like the Borg.
Oh, well, I mean, I could put it back. That sounds much cooler than my voice does normally. Well, you're all going to be assimilated anyway by the end of this. So, there's no shame in copying from other languages. If something works, you should do more of it. So you don't have to be wholly original in everything, and it brings some comfort to people. You'll see familiar things if you're into other languages. You'll see some familiar things, and yeah, they probably totally rip that off from another language. And one of the things I love about Kotlin is its positive community. The people who write Kotlin generally want to help each other. Even on Stack Overflow, I go up and I work on the Kotlin tag when I have time, and generally speaking, the people there are very polite and friendly. The people who maintain Kotlin or write Kotlin, the language, for a living, are on there answering questions. You'll get several authoritatively decent answers for good questions on the Kotlin tag on Stack Overflow. It is not a read the fantastic manual community. I hate those communities. I really just don't have time for negative communities. And that's one of the things I really love about Kotlin, is that no matter what you're doing, whether it's Android or Java or multi-platform or whatever you're writing, the people are just happy to help each other. And it's infectious. I think it's a great attribute in a community. And a positive community is a good attribute for any language to have. So am I alone? I mean, we're all supposed to be a little alone right now, but you understand what I mean. In 2017, somebody said, hey, we've got this thing called Kotlin. Can we, and it compiles down to Java 6, could we use that with Android? And everybody kind of looked at each other and said, sure, give it a try. It should work. And it did, to the extent that in 2018, Google said, well, not only does it work, you should prefer it over Java. And in 2019, they said, we like it so much that Android is now Kotlin first. So all of the examples are being rewritten in Kotlin. Kotlin bindings, Kotlin DSLs are coming first over the Java examples. For Android, they prefer you to write things in Kotlin. Most of the apps that are being written now are in Kotlin for Android. And I think that's just an amazing step to take just in 3 short years. I work on Spring a lot. Have worked with Spring for a very long time. Kotlin is fully supported in Spring Framework since version 5, which came out a little while ago, I guess maybe about 2 years ago now. It's an option on start.spring.io if you are writing Spring Boot applications, which again, I am. The Spring team went through their entire library and added not null annotations. And I said you can bring code in from Java, but if you annotate it with your Java code with not null or nullable, the nullable is a little easier to manage in Kotlin. Otherwise, you have to kind of take a guess at whether it was nullable or not. But they went through and did that, and it's really seamless. I write Java Spring Boot and Kotlin Spring Boot, and sometimes in the same project together, and it's completely seamless, and it's just wonderful work. And Spring always does the Spring team does a wonderful job on documentation and examples. They're all there. Compilable documentation for Kotlin. You can compile your documentation and run unit tests on it. So that's there, and they're doing more and more of that. If you're into Gradle, I use Gradle. I'll confess, I still use the Groovy DSL, but the Kotlin DSL is there. I use the Groovy one because I work for a company that has a long and invested history in a lot of the Groovy stuff, and it's just easier. But I am switching slowly over to the Kotlin DSL. The benefit is the Kotlin that you can debug it a little bit easier, and the type safety provides a little bit cleaner discovery of what's going on. But it's there. People are starting to use it. So let's talk about syntax. This is we're all software developers. This is hopefully what we're here for. Kotlin has this notion of variables and values. Now, variables can change, they vary, and values cannot change, they're immutable. So in this case, we've got a variable named place. whose type is string. Now, if you'll notice, the type and the name are backwards from one another as they would be in Scala. They're backwards from Java, and you'll see in a minute why they're that way. So if we have a string and we set it to Salt Lake City, it's a var. I can set it to Utah. That's not a problem. On the other hand, if I have a val, meaning it can't change, it's immutable, called name, which is also type string, and I set it to my name, Todd, I can't go later and set that to my daughter's name, Emma. It just won't compile. The compiler won't let me continue on with that. Okay, this is a core concept. And when you write Kotlin, it's really nice to be able to assume everything is a val until proven otherwise. So you're writing safer code that way. One of the other features you'll hear about in Kotlin is called type inference. So in this case, I want you to look at these two examples. We've got this val d, whose type is int and value is 2. We've got some text, which is a type string, and its value is Todd has $D donuts. So sidetracking just for a minute. When you print that string, it'll do what you think it does. It'll interpolate that string and print Todd has 2 donuts, which sadly is not true, and I don't get to go to a new city and find all the good donut shops, which bums me out. So I'll have to discover them here. But I want you to look at these types here, int and string. Now, to me, it's pretty obvious that that d is an int and text is a string. So I can leave them off and declare them this way. So I can say val d equals 2. D is still an int. The code that gets developed or that gets built, the bytecode, is still the same. There's no difference at all. I just leave the types off. Now, sometimes you can't. Sometimes you might want them on there for clarity or to specify a specific interface or whatever. But in most cases, if it's obvious, you don't have to specify what those are. You'll also notice in these examples that I'm giving you that there are no semicolons at the end of any of them. Semicolons are completely optional in Kotlin, and I don't know anybody who exercises that option, and you get used to that really quickly. Equality in Java is one of those things that I found confusing at first, and a lot of newbies find confusing, and seasoned veterans find confusing as well, because you've got double equals for primitives, right? And you've got dot equals for object equality and then you've got sometimes you do referential equality, which is also double equals, and so it just gets really confusing. And in Kotlin, we just do double equal for all structural equality. So under the covers, it's going to write the correct code for you. If I say name1 equal dot equal name2 to uppercase, that'll be true. They're the same. They're the same value. They have the same value. Kotlin underneath the covers will write you the dot equals Java equivalent that you would have to write. But as a developer, you just remember structurally is double equal. And if you need referential, meaning do these references point to the same object in memory, you can use triple equal, because that's a less common example or less common operation. You have one extra character. And so again, these are like, this is a little thing, but it adds up and it makes it a lot cleaner and easier, less ambiguity. So like, again, I've shown you several little things, but it's starting to add up. Now, if you're following latest Java, this might not be all that spectacular, but it's available now and you can run it on every platform that I mentioned. So if you've ever done anything with JSON or SQL or regular expressions, you have a lot of escaping characters. So in Kotlin, we have these thing called raw strings. If I put three quotes around it, I can put whatever I want in there. New lines, it'll render exactly as I have it in there. And I can do interpolation. That's one thing that Java doesn't do. Java's raw string implementation does not do interpolation, so I couldn't say name equals $name. I have to do string builder or whatever we're doing in Java these days for that. Now, under the covers, when we do string interpolation, I should mention that Kotlin is writing the correct code for Java as it would. And in this case, it's doing the same thing. It's writing the correct builder implementation or whatever bytecode is appropriate for the string you're given. And again, this is really nice. I write a lot of JSON and SQL queries in my code at work. And And I love having the raw strings and not having to think about escaping anything. So null safety, this is the big one. We'll go through this one. We'll go through this one slowly. So when I say the type is string, here I have a name string, that's never allowed to be null. I can't set that to null. The compiler just would not let me. On the other hand, if I put a question mark at the end of my type, so in this case, we have a salary, which is int with a question mark at the end. That's allowed to be null. Now, some people call that a maybe int or a nullable int or an int. I call it a nullable int. Some people, pick whichever one you find the most hilarious and go with that. But you can call that salary null now. Now, you hear this thing like nulls are the billion-dollar mistake or whatever. Now, I don't think that nulls are a problem. I think null is a perfectly fine way to represent a state. It's allowing programmers to chase a null reference. That's the problem. And this is where Kotlin really comes to help. We have this thing called the safe traversal operator. So to give an example, we've got this a variable named city, which is type nullable string, and it's set to Salt Lake City in this specific case. Now, I can't call toUpperCase on city because it might be null, because it's a nullable string. And to get around that, I need to use the safe traversal operator, which is a question mark before the dot. And that's saying, if city is not null, call toUpperCase on it. Otherwise, that whole expression is null. Okay? Another way to get that Java or Kotlin helps you, Kotlin helps you with null references is this operator called Elvis. So in our case, we've got a value called lowest, whose type is nullable int, and it's a list of 1, 2, 3. Now this list of is built into the Kotlin language. This is another small, nice to have thing. It creates you the correct type of list. In this case, it'll probably be an array list, and it'll put 1, 2, 3 in there. And when you call min on there, which is a function on list in Kotlin of ints, it will give you a nullable int, because Kotlin is not smart enough to tell you that the list is not empty, so there's definitely a minimum value in there. It's just not smart enough type-wise to do that. So it returns you a nullable int. Now, I don't want a nullable int. I know there's something in there. So what I can do is I can say this Elvis thing. And now it's called Elvis because apparently if you shift him on his side, he looks like Elvis Presley, and I'm like the only human being in the world who does not see this, but everybody else does, and so hopefully you do too. So what Elvis does is it says if the left-hand side, so the min call, is null, just evaluate the right-hand side. Now in my case, I'm just saying 0 here, but it could be any expression. I can do another list of or another call out to another function or do whatever. It can be anything, any expression that's arbitrarily complicated. Again, I'm just saying 0. So a lot of times you'll see these together. We'll see println here. This is another built into the Kotlin language. Instead of saying system out println, we just say println. We're saying if our city is not null, do toUpperCase on it. Otherwise, the value is unknown. So you see these two working together to get around nulls, and you work with the type system. And this is great because now we can, as developers, this catches us. The compiler is catching us and helping us move past these. We're not checking null pointer exception code into production, and it's just easier to reason about. And with nulls as a proper type in the system, it's easier to run inference checks on those. Now, this is the part of the talk that I always think about getting rid of, but there's this manual override that you should be aware of. So we got our example again. We've got a lowest, and we've got this list of 1, 2, 3, and we know there's something in there because we can see it. It's plain as day. So I can just, at the end, I can use this bang bang, which tells Kotlin, turn off all null assertion checking. Just I'm the person. I know better than you, stupid compiler. And just trust me, there's something definitely in that list, and it just get rid of the null checking. And it'll do it for you, and you'll move about your day and you'll be fine. until you do something like this, where you say, give me an empty list of int and get them in value on that. And then you will get a null pointer exception because you said you were smarter than the compiler, and it's laughing at you now in compiler language. So you can get null pointer exceptions out of Kotlin. You just got to go shoot yourself in the foot with that bang bang operator to do it. So remember all the names because it's important, and they might come up again. Question dot is safe traversal. Question colon is Elvis, and this is the hold my beer operator. If in Java is a statement, meaning it doesn't produce a value in and of itself, it only has side effects. Now in Kotlin, it's an expression. So in this case, I'm setting my value status to either success or fail based on some code equaling 42. So the value of this if expression is my status. Try catch is also an expression. So in this case, I'm trying to take code, which maybe presumably is a string, who knows, that's got 2 int, and if it's not, if we catch a number format exception, we'll just return 0. Now, this try catch works just like Java's. You can put anything arbitrarily complicated into the catch block. I'm just putting 0 just to just so I can be brief with it. So we either convert our code to some legitimate number, or it's just 0. And it's really nice having try catch as an expression that way, so I can make code a little bit easier to follow. Now we have got this, I know in Java, we've got new switch expressions coming, or are here, depending on which version and which compiler flags you're running. But Kotlin has got this concept of a when expression. In this case, I've got x, and I'm saying when x, and we don't know what x is. In this case, it doesn't really matter. And we can do all sorts of tests on x. We can say if x is exactly 0, or is in this range of 1 to 10. That 1.10 is Kotlin's concept of a range. Ranges are top-level constructs in Kotlin. We can see if it's in some set. We can see if it is some type. If x is equal to the result of calling some function. Otherwise, else, do something else. So if the left hand matches the right hand, is returned or executed. It can be any kind of arbitrary expression, again, on the right-hand side of that arrow. So this is really, really handy. In these cases, I should point out that when could also be used as a statement, but when I'm using it here as an expression, meaning it's returning a value, it needs to always return a value. So that's why we have that else at the end. It needs to be what they call exhaustive. Every input must have an output. So in this case, I'm covering that by saying else, here's your default answer equivalent, right? So it's like having default in a switch statement. And we'll see an example later of when you don't need that, when you have an expression. But generally, if you use it as an expression, you need to have every base covered. If you use when as like a fancy if-else block equivalent, and you're just doing side effect stuff and not returning a value, you don't have to have every base covered. You can just cover the cases you care about and fall through for everything else. And I should mention that these cases don't fall through. So if we match 0, x is 0, I don't have to worry about it matching something else later. It's going to break after it evaluates the first one. And I like that because I can count on one hand the number of times I wanted a switch statement to fall through and not break in Java and a lot of other languages, and it drives me crazy. And I think this is one of these great developer things like, well, why doesn't it do the right thing by default? Why doesn't it do the most common thing by default? This is, again, a little thing. It's adding up. So expressions break by default. If you want them to continue, you can have them continue. And now that we know about this, we can take advantage of what's called smart casting by the compiler. So we've got this when statement here. So again, I'm not handling every possible case of x here. I'm only checking for int, string, or int array. But what's interesting is if you look at the right-hand sides, those x's are doing different things. I'm saying if it's an int, print whether it's even. If it's a string, print its length plus 1. And if it's an int array, sum it up for me. Now, how does it know to do that? Those I can call sum on x on the right-hand side. It's smart casting. It's assuming hey, if you're testing on the left-hand side and you want to, you're testing on the left-hand side, you want to do something with it on the right-hand side, you probably wanted that type. So I'm just going to assume that X is the type that you tested for on the other side. And that's really nice because then you don't have to have this clunky, casting or anything like that. It's just going to do it for you. This works for null as well. If X cannot change between the time you test its nullability and the time you use it, you can smart cast from a nullable type to its non-nullable type. So in this case, presumably X is some private variable. If it's obviously a public thing and somebody can come along on another thread, at least even in concept, and change X's value, Kotlin won't let you do that. Smart casting in that case isn't so smart. It makes sense when you think about it, but you just got to watch out. Like why didn't that null cast is a common question in this specific case, if X can change. So Kotlin has classes just like Java has classes. Kotlin doesn't have a concept or a keyword for implements or extends. You just say colon and then give it a comma delimited list of interfaces that you're implementing and a class you're extending. Still single inheritance. You can only extend from one other class, and order doesn't matter. So in this case, I have a class called entity, and it's implementing some interface, and it's nice and compact. Now, the deal with classes in Kotlin is they are final by default, meaning you cannot extend them. I like this. I think it's nice and safe. It's putting the focus on the developer to say, hey, you need to think about this as a developer. Do you want somebody extending this or not? And I like that. I like the fact that as a developer, I now need to think like, does anybody really need to be extending this? And if somebody does, if I do want somebody to extend it, I have to declare my class as open. So I can say I've got this customer and it extends entity, and by calling it with the parens, I'm calling entity's constructor. And now I can have customer that extends entity. Now customer can't be extended, just entity in this case, because customer is not closed, it's not open. So if we go back to Java, we look at this, this class called customer. We've got this private field called name, and we've got a getter that is just getting, and a setter that is just setting. We have collectively as a group have probably written, a million of them, and or our IDEs have done it for us. This is extremely common in Java. It's part of the the original Java Bean spec. And we've stuck with it, and it's fine. It works great. It's a good idiom to have in Java. Now this is the same code in Kotlin. It's doing the same thing, and I'll walk you through it. I swear to you, you're not losing anything by doing it this way. So I've got this class customer, and I've got a variable called name, which is a nullable string. And so what's happening is, under the covers, if you compile this down to bytecode and then back out to Java, you will essentially get this same class back. What's happening is it's giving you a getter that just gets, and it's giving you a setter that just sets. There's no magic in there. There's nothing crazy going on in there. For example, if I say val c equals customer, one thing I want to point out here is there's no new keyword when I'm creating that customer. There's no new keyword in Kotlin at all. And that is the only thing that I think I don't like about Kotlin, but not for the reason you think. Because when I'm writing Java, I forget to put the new keywords in, and they're scratching my head like, why isn't this compiling? Why doesn't this work? Why doesn't this work? And I'm like, oh, it's because I'm so used to not having to type new anymore that I stopped doing it. So again, no new keyword, no semicolon here. And I can say c.name equals Todd. Now it looks like, if you're used to Java, it looks like I'm just putting that value Todd right into that field, but I'm not. What's happening is it is actually calling that the setter that it's creating under the covers is actually getting called for me. And when I print it, this is a better example of string interpolation. I'm saying this arbitrarily complicated c.name down here. It's really calling the getter for me instead of just hitting that bare string. Now, what good is that? The benefit of this is if I'm just getting and I'm just setting, I'll just see that field, or that property there is what I should call it, right? I'll see that property there. I won't see anything around it. You know, I've been there where I've pulled up a class and it has 50, you know, some JPA class or whatever has 50 fields on it and 50 getters, 50 setters. And I got to go look to see if like somebody like me has gone along and put something funky into one of the getters or one of the setters that I need to be aware of. In Kotlin, I can still override the setter in this case. I want to, whenever somebody sets in this case, I want to uppercase the name. I don't want it lowercase. I want it uppercased. Now, I'm doing something different here, right? I'm doing some different thing on the setter. It should stand out, and it does. And this is what I talk about, less cognitive load. The things that are on the screen are the things that we're doing, we're caring about. We don't care about getting and setting in any other case other than this, because we can just assume getting and setting is getting and setting. In this case, set is doing something interesting, or not that interesting, depending on how you look at it. Now, you can make them private, and you can override the getter. The getter does the same thing. If we want to uppercase on the way out rather than the way in, we can do that too. And again, interesting things should bubble up and you should be confronted with them, and not interesting things should just be the easiest thing in the world to do. One of the things I like about properties in Kotlin is that you can delegate them. So in this case, if we've got a country and we have this GDP, which is calculated by this very slow calculation. In Java, if we wanted to wait and delay that calculation until somebody needed it, we'd have to synchronize, we'd have to have some sort of nullable thing, we'd have to go off and calculate, we'd have to do some, you know, some checking and locking. But in Kotlin, I can do that by saying GDP is an int implemented by lazy. Lazy is the lazy delegate, and I'm handing it a lambda here, which has just slow calculation in it. So this class will compile, and if nobody asks for GDP, it'll never get calculated. If somebody asks for GDP, it'll go off and calculate it and memorize the answer and give whoever asks for it next that same answer again. So you only pay the price once and only if somebody uses it. Now, to write that code in Java, again, would be some kind of effort. But in Kotlin, you get that for free just by doing this. Delegating can also go to the class level. So let's go back to Java and we say, we've got this interface called huge interface. Now let's suppose it's got like 50 things on it, right? It's like a list or something like that. It's got 50 different methods on there. Now, if I want to implement that as a Java developer, I have two choices I can make with that. I can make it easier on you, the consumer of my new implementation, by saying I'm implementing huge interface, and I'm taking an implementation of huge interface from you. I'm wrapping it, right? And I'm going to call that the backing. And then I'm going to implement every single method in huge interface and call through to the backing that just is, you know, you're call this function, it just calls the backing, the same equivalent on the backing, except for maybe the 3 or 4 different functions that I care to override, and then I'll handle those myself, right? So it's kind of a pain in the neck for me because I've got to go write a bunch of boilerplate code, but it's better for you because you get to give me the implementation of huge interface that you prefer to wrap. Now, the other way we could go with this is say we're extending some implementation, meaning you don't get to decide which implementation. I'm going to pick, you know, again, we're doing lists. I'm going to subclass array list or linked list. And maybe that's not a great choice for your use case, but the benefit to me, the developer, is that I don't have to implement everything. I can just implement the functions that I care about, and everything else will get delegated to the superclass, right? Now in Kotlin, we can do both of those at the same time. I can say I have this class called myImpl. It takes in H, which is a huge interface. The class myImpl implements huge interface by H, and that tells Kotlin, hey, anytime somebody calls a function on this class and it lands in huge interface, just go off to H and call it on that. Delegate it through to H. I don't care. Unless I implement it here in this class. So I can implement the 3 that I care about, and you as a consumer can say, here is the implementation that I want you to use for the backing. And now I did this for a project a little while ago. I wanted a list that worked like Python. So it said, give me the negative first element of the list. It would just work its way back around to the end and give me the last element of the list, right? Or the negative second, it would go 2 from the end, right? So I could address my list circularly. Now in Java, that would have been a big pain in the neck. I would have had to implement all those things on list. But in Kotlin, it's like 5 lines of code. It's like a couple of getters that I had to implement, and that was it. And I did it this way. And it's really, really sweet because there's no code to it at all. It was really elegant. I was very happy with the solution. Kotlin also has the concept of sealed classes. I think these are coming. I want to say Java 16, 17, somewhere around that time frame. These are coming to Java, but they're here now in Kotlin. A sealed class is message is a sealed class, and by putting all of these classes in the same file as message, I'm telling Kotlin there will never be any other subclasses or of message ever. Okay, I should just stop and say that everything in Kotlin could go anywhere. You don't have to have just one class per file. You can have all your classes or all your interfaces in one file. You can write an entire application in one file if you choose to. There are no restrictions on that. So that's why this works. I can define 4, 3 classes in an object. So, I've got a message, and let's presume it's, I like message passing architectures because I think they're easier to reason about just for me. So let's pretend I've got a message and it's got this thing called start server, and it gives me the name of the server, and then same with stop server. And then I can pass it some command called count server. And because count servers doesn't have any state with it, I can declare that as an object, and Kotlin will just declare it as one object. You get singleton for free, basically, by calling something an object. And when I use that, again, here's our when expression. You'll notice I don't have an else in here because message is a sealed class. Kotlin is smarter to say, this is exhaustive. We know every case is handled. So this is really where sealed classes are really nice. You can mimic this with enums, but if you have state, it's really nice to be able to pass, to have a sealed class structure for something like this. And so we'll handle, each one of the messages that could conceivably come into our system. So let's write a POJO, right? We've all done this. If can we all close our eyes and type this into our editor, and we'd probably be great. We can all do this because we've done it enough times collectively. So we've got a person with a first name and a last name, and I'm just going to check this in because nobody on my team is going to complain. All right, we need getters and setters, right? We can't call it a POJO without getters and setters. So I'll get IntelliJ to write those for me, or whatever, Eclipse or whatever. I'm getting my IDE to write the getters and the setters for me because it's just formulaic and it'll do it. And the same thing with constructors, right? We need a no arguments constructor and an all arguments constructor. We'll get the IDE to write those. We'll get the IDE to write equals and hash code because we need those in order to put them into maps and whatnot to draw inference on their equality. And we need a toString because we're going to be debugging the best way possible, which is doing system out printlns. So we're going to need a toString, right? And so we look at this thing. We wrote 3 lines of actual code, and our IDE wrote the other 47. So this is the equivalent in Kotlin. So it's called the data class. We'll talk in a minute how these differ from records in Java, but we'll go with this for now. So each one of these first name and last name is a property, right? Because I'm calling them in their constructor to person. They're exposed as properties. In this case, they're just vals. So you only get the getters. You don't get the setters at all if they're val properties. So you're getting getters and setters as properties by having it be a data class or just a class. That's just how properties work in Kotlin. Because it's a data class, you're going to be given a toString function. It's not shown here. You don't have to write it. If you don't like it, you can extend. You could put squigglies here and override that and define it yourself. Same thing with hash code and equals. You get a sensible implementation. I don't think I've ever written hash code. I think I've always had something do it for me because they're difficult. They're difficult to get right, so I offload that onto somebody else who's better and smarter than me. So you'll get a default version for your data class, but if you don't like it, you can always write your own. And you get copying classes. So if I've got a val, which is me, is a person and his name is Todd Ginsberg. If I want an exact copy of that data class, I can say, but just like one or two little changes, I can say, copy me, but change the first name to my daughter Emma. And it'll give me a new version of person with my daughter Emma's name. Now, this is great if you have a data class with a lot of fields and you want just one or two things or a lot of properties and just one or two things changed. You can do that with the copy constructor. You can also destructure. This is helpful for certain cases with lambdas. If I've got a person, I can bust it into its component parts and say val first and last is me, and it'll know position-wise how to bust that up. I don't use that too often, but I like to point out that it is actually possible to do that. So let's talk about functions. They start with the word fun. That's how you know you're having fun with them. And we'll call it, you can see again, we've got a function that has the name first and the type later. Maybe you see where this is going. We'll call it generate random number, and it returns a 4 because I rolled a 4-sided die. And that's what it came up with. Now, in this case, if I can make my function a single expression, in this case 4, I don't have to have squigglies and I don't have to have return. I can just say this function equals 4. It's the same code, it does the same thing. It doesn't really matter which way you do it. But if you do it this way, you can leave off the type. So you can leave the type off your function. This is great for private methods or things that you know, or private functions or things that you know people aren't going to get confused about. Now, I don't tend to leave them off. I like the documentation of what type there is. And there's a danger here that if I generate a random number and I change it from 4 to 4.0, I've changed the type of my function, maybe without realizing that I've done it. And you can imagine more complicated examples with collection types or things from your own personal libraries or whatnot. So it really just depends when you would leave them off or when you would put them on. I think general guidance is if it's a public-facing function, to leave the types on just for documentation and for clarity, so that if you do change the working of the function, that the compiler will catch you if we mess that up. So it's there as a facility. You don't have to use it if you don't like that. Functions, arguments can have default values. So in this case, we've got a random function who's taking an offset, and we're saying if you don't provide an offset, it's just 0. So we're saying random is the offset plus 4. So I can call that without any arguments, in which case offset will be 0, or I can call it with some argument, and that will be the offset. So random 1 in this case is saying offset is 1, so our random is 5. And that's really handy. If you're adding, you can use this to add parameters. So I've had, if you've done Java any length amount of time, you've write this great function, and you'll be like, you know what, I've shipped it, but I really wish I could add that third parameter to it that does, turns on logging or does whatever it is you need to do, right? So in Kotlin, I can just add that. I don't have to have this chaining thing where the 2-argument version of the function calls the 3-argument version of the function and has some sensible value. And again, that's buggy, that's error prone, where I forget to pass something along, or I don't set the value isn't quite so sensible, or, and you can't really do anything about it anymore. I've definitely screwed up and skipped one of the chains and don't get a good default value or something. I've definitely screwed that up. So I like this, that I can just add that third argument on here. And if people want to call it with either 1 or 2 or 1, 2, or 3, it really doesn't matter because the default argument, or the default value, will come in and help me with that. And it'll write the correct code. When you decompile this back to Java, you'll see it the way you think it is. You'll have both versions, and there's what's called a bridge method hidden in there that you don't see when you compile it. Functions in Kotlin, the parameters are named. So in this case, we've got our combine again. I can call it the way we traditionally call it with 1 or 2. And I can name the parameters. I can call it with first or second or first. If I'm calling them by name, I can call it in whatever order I choose to. Now, the thing to watch out for in Kotlin or any language that has name parameters is that your parameter names are now part of your API. So if I change from first and second to 0th and first, I'm going to bust anybody who called second, right? And change the meaning of one of my fields. So just be careful if you're doing if you're working in a language of name parameters, Kotlin or any other language, that you pick good parameter names and stick to them, or people might get busted if you change them between versions. Function names, this is really interesting I do this for tests, really just only for tests, because I can put anything between tick marks in Kotlin, it'll be fine. So I can have spaces or emoji or whatever I want between these two tick marks, and that is a valid function name, and I can call that function. I can put that, I can put that function, I can call that on any object. It's really just done for tests because nobody's calling these except the JUnit engine, and we don't care how difficult it is for them to do it. But it's nice for us because I get to read that rather than reading this compact thing or have underscores in there or whatever. I can just write a full English sentence here, and it's great. So keep that in mind. You can do that. Just as a side note, the tick marks are also how Kotlin gets away with declaring how you can call Java code from Kotlin if the Java code uses a reserved keyword in Kotlin. So when is a keyword in Kotlin, but not in Java. So if you're using Mockito, how do you call when? Because it's a keyword in Kotlin. You put the tick marks around it. That's one of the ugly things about pulling Mockito into Kotlin, is that you have to do the tick marks, or you have to write a function that's called like whenever that calls when. So the tick marks, that's an interesting way around problems, and it gives you a nice full English sentence or full whatever language sentence for your function names if you choose. We can override operators in Kotlin, not like some other languages where you can go completely bananas and make up symbols that look like things that only you see. You have to pick from a list. You can't go completely crazy doing this, and you have to say it's an operator and I'm overriding it, right? So we have this predefined list. I just pulled these out of the documentation. So if we want to do this expression on the left, we say, A plus B, if my objects, if it makes sense to add them together, I can implement the plus function on my object, and I'll do whatever I want to do, return a new value of A plus B. There's you can see the symbols that we can deal with here. We can treat our object like it's some kind of container, like a map or a set, and implement contains. By implementing contains, I get in and not in. So if I say A not in B or A in B, I just have to implement contains. I can make my object look like it's an array, or again, this is common for maps. I can say A of I or I of A by implementing get, and then the set equivalent by implementing set. I can do plus assign, minus assign, times assign, things like that. By implementing compare to, I get the full range of comparison symbols for free. Right, so it's not like I'm going off and implementing my own symbols or going crazy with that. You have to pick a set. And I think that's a really pragmatic approach that the Kotlin developers took. It's like, hey, people do these things. This is a very common set of symbols or constructs that we want to be able to overload, but we don't want people to develop spaceship-looking things and go change the language to the point where it's just confusing to look at. It's pretty obvious when you see the greater than symbol what somebody's intent is with that. It really means one specific thing. So I think this is a pretty pragmatic approach over Java, which doesn't let you do any of these things except for maybe plus, and then in some cases, and some languages which just like anything goes. I think this is a really nice pragmatic middle of the road approach to this. So if you've done Java long enough, you've lamented the fact that some function or method is not there, and you've written a static. You've got this dumping ground of class called util or date utils or string utils or whatever it's called, and you've got just all static methods in it, and that's fine. That's how we work around these problems, right? So in this case, we've got the static function called isEven. We give it an int, and it tells us whether it's an even number or not. And this is really common. Now in Kotlin, this is the same equivalent thing. This is called an extension function. I've got int dot isEven. It's returning a Boolean. Again, I can leave that off in this case. And it's saying this, meaning the int you're calling isEven on, mod2 is 0, then it's even. Otherwise, it's odd or not even. And to call that, I just say 2.isEven. I don't have to say, extension functions .isEven 2. I can just say 2.isEven. Now it looks like isEven is part of my language, like it's always been there. Now int isn't getting changed. I'm not physically changing anything. I'm not patching an isEven function into int. It's just like any other static function you'd call. It has to be in scope. It has to, for me to, or I have to import it in order to use it. And this is what the vast majority of the Kotlin standard library does. It takes Java classes that exist and it adds these extension functions on. So the standard library has really got everything that you think it's not, that we didn't do in Java or whatever other language. It has a lot of those things because of the power of extension functions. And because you don't have to put them on a specific type, you can put them on object or any. Kotlin's equivalent of object is called any. You can put them on that, or in this case, auto closable. So in Java, auto closable, you can do this try with resource thing that came in Java 7, right? So I'm saying, get me this connection. I'm going to use the connection. And at the end of that try block, because connection implements auto closable, that's just going to get closed off for me. I don't have to think about it. I don't have to manage the resource myself. Now in Kotlin, this equivalent is done by the use extension on auto closable. And I can say, get me the connection, .use, and then give you the connection into this Lambda, and I can do whatever I want with it. And at the end, use will close that up for me. And I think that's kind of cool. Another good example is the apply extension. Apply is way more common. You'll see this all over the place in idiomatic Kotlin code. Now I've got this person, Dr. Robert Hume, age 47. It's an expression to create the person in 2 statements. And that's fine, but I can create this as one single expression by saying apply. So what's happening is when the apply gets called, it's being called with this reference being the person that we're calling it on. So I can just say name is whatever and age is whatever. And this is really nice and compact. And I can do this on any object you want, because apply is an extension on everything. It's really nice as a lightweight builder if I've got more than one object that I'm trying to apply to. So I can create this person with one single expression. So I can say, here's the address, and I'm saying create an address and apply their Dr. Hume's address to it. Right, so this is nice. You'll see apply a lot of places. There are several other core ones that I'm not going to show you because I think, frankly, for the amount of material we have here, it's just going to get confusing. But there are several others in here that are idiomatic, and it's extensions in Kotlin are a natural way to construct your code or extend other people's code. Kotlin also supports this notion of higher order functions. Now, a higher order function is a function that either takes another function as an argument or returns a function as a value. So I've ripped this off from the Kotlin standard library. It's called measure time millis. It's taking a block, which is a function that takes nothing. So the parens mean has no arguments, and its return value is unit. Now, unit is Kotlin's equivalent of void. I don't know why they didn't just say void, but they called it unit, and we all have to live with that. And this function itself returns a long, and what happens in the middle is it starts a timer. It calls that block, that function you gave it, and it returns how long that block took to execute. So I can measure the time this block takes. So presumably the block doesn't return anything. It's just the side effect. There's varying utility in a method like this, but this is the simplest one I could come up with to show you. And to call that, if the higher order function is the last or only argument to your function, I don't have to put the parens in to call it. I don't have to say measure time millis, parentheses, squiggly, slow time query, squiggly parentheses. I can leave the parentheses off. So now it looks like measure time millis is part of the language. It's like it's always been there. Now it's not. It's just a function that's been put into a standard library. And we can do the same thing. We can get the same benefit to say, have a word there and have some lambda in the middle of it that runs in a context. And it's really nice because now it looks like it's part of the language. Now, this is one of the things that makes DSLs in Kotlin really nice. We can do a whole a whole talk on domain-specific languages in Kotlin and why it's a nice language for that, but that's a lot of material. But this is one of the building blocks for that. So some things on functions that you should be aware of, like classes, they are final by default. As a developer, it's on us to think about, do I want people extending this? Am I okay if people take this and override this function? And I like the fact that it's final by default. I like the safety in that. Arguments to functions in Kotlin are always final. I'm that jerk in your code base putting final everywhere on all the function arguments because I want the compiler to tell me, hey, you're reusing this and you're setting it to something else, because I don't like doing that. So I always mark them final. In Kotlin, they are always final. There is no way to turn that off. I can't say, open argument, whatever. There's no way to turn that off. And again, it may be opinionated, but I like that. As I alluded to before, functions can be defined anywhere. They don't have to be in a class, to the point that the main function in Kotlin can't be in a class. It has to be on its own in a file. Again, you can have whatever you want in that file. You can have other classes, other functions, other interfaces. But functions are top-level constructs in Kotlin. Functions can be defined within other functions. If you're a fan of recursive algorithms, that might be something that you're used to in other languages. I think with default arguments values, that is less and less common of a need in Kotlin, but you can do it. I've done it. And again, if you're into recursion and recursive algorithms, I don't tend to write a lot of recursive algorithms at work. I tend to write it in a lot of toy code or play code that I do, or like these leak code things. I think those lend themselves to recursive functions for some reason, and I like them. But Kotlin, at any rate, Kotlin supports tail recursion. So if you know what that is, it supports it. And if you don't know what that is, you're count yourself lucky. So I haven't mentioned checked exceptions at all. Kotlin does not support checked exceptions, and by that I mean you can't declare that a function throws an exception and expect anybody to do anything about it. Now, if you call a Java function or a Java method that has declared exceptions, you don't have to handle them. You can just let those bubble up. Everything in Kotlin is a runtime exception. Everything. Now, you can catch them. We've seen an example of a try catch. So clearly there are exceptions and you can deal with them, but you don't have to declare that your function throws an exception, and you don't have to force your consumer to handle that exception. And there's a long and storied history of arguing about this on the internet. You can go read up on the pros and cons of that and yell at me later if you choose. But this is where Kotlin came down on that, is everything's a runtime exception. It's taken me a little while to get used to it, but I kind of like it, I think. I want to show you a couple of quick things about lambdas. So in this case, we've got our friend list of 1, 2, 3, 4. We're filtering. We're saying if x is even, I want to keep it, and then I want to map it, meaning I want to transform it y into, I want to double it, right? So at the end of the day, 1, 2, 3, 4 turns into 4 and 8 because I throw away 1 and 3 with the filter, and I double 2 and 4 with the map. Right. So the point I want you to look at here is this x and y, the x and y. So I've got this x on the left-hand side of the arrow and an x on the right-hand side of the arrow, and it does the same thing, right? I'm always got one thing, and then I'm using it. I name my argument, and then I'm using it. But in Kotlin, if that's the case, I can just say it. I don't have to give it a name. I can just assume the default name for a lambda argument is it. Now this is totally ripped off from Groovy. It's a great idea. You get really used to this very quickly. The only case where I think it falls apart is if you're nesting lambdas and then you're like, which it am I talking about? So giving them names in that context, going back to this state is probably worth doing. But you don't have to if it's a simple case like this. I think this is just a lot easier to read. It's idiomatic. If you have one argument to your lambda, most people will just use it. We can do type aliasing in Kotlin, and this is just a convenience for the developer. The code that gets created that I'll show you examples. The code that gets created is exactly, precisely the same. We would not be able to tell the difference between the bytecode. So in this case, we've got some function that takes this really really ugly type here, which is map of some type of list of string, and that's just ugly to look at. It's probably necessary, but it's really unappealing to look at. So what as a developer I can do is I can say type alias operations, I'm giving it a fancy name called operations, is this ugly type called map of some type of list of string, right? And then anywhere in my class that I want to use that ugly type, I can just substitute operations. Now again, this is just for me and you. The compiler is still going to have the ugly map of some type of list of string, but we're going to get to call it operations when we're typing our code, when we're writing our code here. And I think that's really nice. That's also really nice is if you're writing some code, you're not really sure what you want the eventual type to be. You can just, you can alias it and then switch it out later. I've done that several times when I'm doing TDD and I don't really know what I want to do yet. I'll alias things that I don't understand yet and then settle on a type later without having to change 15 different method or function name arguments. I can just change a type alias value. So that's pretty nice. I can import alias too if you're old school DAO writer and you've got you're doing the old dates, for example. This is just probably not a relevant date anymore because we've got 19,000 date libraries for Java. But you've got two classes with the same name. Maybe you've got one system and you're calling to another, and your DTOs are all named the same, right? Customer DTO is named the same in every system, right? So you've got more than one object with the same name. In Kotlin, instead of fully qualifying them, I can import them as util date or as SQL date, and then refer to them as util date and SQL date in my code, rather than having to fully qualify them in my code. Now, the single best trick you can do in Kotlin is to do something like this, is to import them like that, and see how long it takes somebody to notice. But don't tell anybody that you got that from me. Just do that and totally take credit for it yourself. We're going to finish up syntax section with my favorite Kotlin syntax thing that took me a real long time to get around to. Like, why did I care? Part of the problem with Java generics that you'll hear is like it does this. It throws the types away, right? The type erasure. So when you say I have a list of string at the runtime, it's just a list of object because the Java runtime, the Java compiler just thrown the types away, it's checking that you're not passing anything other than a string in there. But once it knows that it's compiled fine, it doesn't care what the type is and it just throws it away, right? So at runtime, you can't get what that list really has in it without actually testing the classes in there. So in this case, I want a logger, right? I've got this logger and I go get logger, and it's got this metrics class Java, which is Kotlin's like super ugly way of saying, give me the Java class of this metrics class. But what I really would like is to just say, give me this generic logger of with just calling it with a generic and just say of metrics, right? But I can't because, again, type erasure. We don't know what metrics would be because it would get erased, right? So in this case, if I wrote this, the generic T is gone. We don't know that it's metrics. It's just gone. But in Kotlin, I can get this back by adding these two keywords on here. I've got inline, meaning anytime Kotlin sees this function call, if I call logger of, anytime you call that, it's marked as inline. Instead of actually creating a jump to that point in memory where the function is, I'm just going to copy and paste that function into the call point. So it's Kotlin's compiler is taking that code that we have, logger, get logger of T of class Java, is going to copy that into the call point. Now, because it's doing that, I can say, while you're in there at compile time, this T is reified, meaning remember what that is, and hard code metrics in there. So when this line of code gets copied into its call point, it's going to say logger.getLogger metrics class of Java because it's reified. And now I can do something like this. And this took me a real long time to understand why I cared about it, but now I use it everywhere. So if I ever have a class or a function that I need to pass a class name to or a class to, I will go and quickly write a reified wrapper for it that just calls it and does the ugly class thing, so I don't have to think about it. It's really nice. There's several different Spring functions. I guess a lot of the Kotlin Spring extensions, this is what they're doing. So you don't have to, but for Spring so much, but for your own internal things like, like object mappers or whatever, things like that, you have to pass it a class. Write a quick function like this, and it's so much nicer to look at this logger of metrics instead of that ugly thing up there. Now, I'm trying to not go completely crazy with this talk and go, make everybody's head explode. There's a lot of things that Kotlin does that I've left out. A couple of things on here I'll just touch on really briefly. The standard library in Kotlin is really, really nice. It's got the benefit of hindsight. It's got the benefit of looking at all the things that Java didn't add and all the things that, say Apache Commons added. Pretty much any string manipulation thing, anything you think should be on collections, it's there. They're mostly because of the extension functions that I showed you before. The standard library in Kotlin is really nice. It's very rare that I have to write something that parses, that does weirdo collection things, that I write an extension function for it. It's almost always there. I think that's a really nice benefit of moving to Kotlin, is that these things are there. You don't have to think about them. They just exist. Inline classes, I didn't go over those. There's unsigned integers. That's experimental. They're I think about to make that unexperimental, or mainstream. Kotlin 1.4 I think is going to come out this summer. I think if things are still on track, they're pretty cagey about dates. Generally, they release when they're done, which I think is great. But rumor has it it's supposed to be towards the end of the summer for the next version of Kotlin. And I think unsigned integers are going to be mainstream in that. Multi-platform, I mentioned, we can write the same code for multiple different platforms and expect, like how do I deal with strings, or I have a library that needs to behave differently on each platform. I can expect a platform to have an implementation. It's that's another whole talk. Kotlin coroutines is really, really nice way to do asynchronous code. I can write imperative code, but get asynchronous, and it hides all of the state machines and callback hell and all of that stuff for me. It does it all for me, and it's totally safe, and will clean up after itself. It's again a whole nother talk. Kotlin DSL is really great for DSLs. And infix functions, meaning I can have a function in between two things, like how those operators work. Those are all infix functions. You can write your own infix functions. So I left a lot of this out, a lot of details here. I'm going quickly through it. But Kotlin is a really rich language. There's more to it that I'm showing you, and I'm leaving out in the interest of time, so we'll have questions. So in summary, Kotlin makes bad choices explicit or impossible. Even if you don't like what I am saying about Kotlin and you're a Java developer, you should go get Joshua Bloch's book, Effective Java. I recommend the 3rd edition. And you should read this about once a year. It will definitely make you a better Java developer. It'll make you a better Java developer for pretty much any JVM language. And I was flipping through my copy, and I noticed these are just the things that Kotlin does for me. So the developers of Kotlin have taken this advice, from static analysis tools, from Joshua Bloch, from sources like that, and have put them into the language itself, made the compiler do this work rather than the developer having to think about it to do the right thing. Now, this list here is just things that I caught when I was skimming my copy. There's probably more in there. I know there's more in there. But these are things that Joshua Bloch says to do to make effective Java, and these are done by default as part of the language in Kotlin. And I think that's just really cool. The modern language is taking that tooling to the next step. So why do I use Kotlin? I write far less code when I'm writing Kotlin. My boss doesn't pay me to write code. My boss pays me to deliver business value, right? So the business value that I deliver is way more expressive and way more clear. I'm avoiding whole classes of defects. I don't have null pointer exceptions in production anymore, for example, and several other examples I listed here. It allows me, if I want to write in a more functional style. I don't have to. I can write, imperative or procedural if I want to. I don't have to write a functional style, but I kind of like it, so I'll do that. And it plays well with the tools that I had already been using, right? I had already been using Spring and IDEA and Gradle. It plays really nice with all three of those. And just for me, it's just way more fun. I just have more fun writing Kotlin, and I can quantify this fun. Every year, Stack Overflow does a survey of developers and says, what languages do you work with this year, and do you want to continue working with next year? And for 3 years in a row, Kotlin is the second least disliked language on the internet. Second least. And I fuzzed out all the other ones, because it's like completely irrelevant that Perl is the most disliked language on the internet. So if you like what I had to say, you can go to play.kotlinlang.org and you can go write Kotlin right in your browser right now. You can submit code and it'll run it for you. You can send these to your friends, examples to your friends. It's got a bunch of examples you can work through. It'll show you how to write the language itself. There's cones, which are more involved problem sets that you can work through. It's right in your browser. You don't have to install anything. If you have IntelliJ, a moderately up-to-date version of IntelliJ, the Kotlin plugin is already in there. You can play with it there. But if you like this, you can just do it here. If you like to take classes, JetBrains has one at Coursera. I think Google has one as well. There's lots and lots of classes. I had 2 coworkers take this class. They both enjoyed it. It's free. If you want a certificate, I think it's like $50, something like that. I wouldn't get the certificate, but I'm not a certificate guy. But you can take it for free and learn that way if that's how you learn. But I'm always here to answer questions. And thank you very much for having me out. I really appreciate it. I wish dearly that I could have been there in person. I've always heard how beautiful Utah is, and I've always wanted to see it. And I was have to stay at home, so I'm a little bummed with that. But I am glad that I got to talk to you all tonight. I'm hoping you all stay safe and healthy and earthquake free, and that you enjoyed the talk. So thank you, and I will shift back and we'll answer questions. Stop sharing so you don't get that.
All right, very good. So you're back on cam. Todd.
Cool.
So we've got about 8 questions, 7-8 questions that we'll go through.
Cool.
And I'll just start up at the top of the list, and we will work our way down.
Cool.
So this first question, which I'm not entirely sure is meant for you or if this is a general question, but Wayne says, I am retired. Do you know of anyone who needs volunteer programming?
Do I? I mean, there's always open source projects. There's always, yeah. I mean, what we do is interesting, and what we do is difficult, and somebody's always looking for something that we can do. If I were looking to get involved in more programming, I'd get involved with my local JUG. That's what I did when I lived in Chicago, and I did office hours, and I taught people how to code specific things. I thought that was great. Find an open source project you like and see if they can help. I mean, I have the smallest contribution to the ACA project that is conceivably possible. I checked in a 1-character fix to something, and they thought that was great. And you literally can start very small, and people will appreciate it. So, just if you like, say you like the outdoors, go find a nature conservancy and see if they need help with a CRM software. It doesn't, people need these things, and we can provide them. It's really just, especially if you're retired and you got time in your hands, just find things you like and enjoy, and just find organizations that you respect, and just ask them. That's what I do.
All right, very good. Next question. How does lazy determine if it should be run again, or is it only run once per instance?
It's 1 per instance. You could write about a delegate that times out and says, oh, it's been a little while. You'd have to write that delegate, but the lazy delegate is really meant to mimic the concept of this value doesn't ever change, but I don't always want it until I want it. So you can change. I didn't go into it, but you can. And there's an article on my blog. I'll post, when I post the slides, I'll post the link to the article on lazy delegate. There are several different ways to say, I don't want you to synchronize. I want you to just let anybody through, or I want you to, let concurrent users come through and the first thread to finish calculating wins. There's different ways to synchronize on that, but by default, it's everybody synchronizes. Everybody waits on the first caller, and then the same value is used in perpetuity.
Okay.
So once per instance per object. Yes.
Very good. Next up from Jonathan, does Kotlin treat the final expression of a method as a return statement, similar to Scala?
Sort of. If you're doing it the way I said, where it's an expression, then yes. But if you have it as if you're using the squigglies method, then you do need to say return. And that is one of those things that I think I like Scala, and I got really into Scala for a while, and that was one of those things I really liked. I think the reason that we don't do that in Kotlin is probably, if I had to take a wild guess, it's probably for clarity, to say you are returning this value, if I had to take a guess. But you're right, it's not strictly needed in Scala, and it's really nice. But yeah, you gotta do it.
Very good. This next one is coming from, where are we? From Lee. Is a new line the invisible semicolon that terminates a statement? If so, is it possible to create multi-line statements?
Yeah, you can. I mean, you can have multi-line statements if you want to. And again, if you want to use semicolons, or you feel like it's like parentheses, right? You don't have to use them in certain places, but I use them really a lot of places for clarity. You can do that same thing with semicolons as well. But yeah, new line is not treated like a semicolon. The Lexer is, I think, a little bit smarter than that. We could go through, if you have an example you want to go into detail on that a little bit later, Lee. I can pull up my IDE and we can check it out. But yeah, I feel like multi-line statements are definitely a thing. The new line is not going to be a semi.
Nice. Next question from James. Is there a use case in which when is a better choice than if, or is it just a choice of style?
That's a really good question, and this comes up in Code Reads at work a lot because I've got a lot of people transitioning. It really is just a question of style. I think it does look nicer if you've got more than one case. So in some cases, if you say when, and then you've got the thing that's interesting, and then an else, probably just do an if statement. But if it's more than one case, and their cases are small, where they're meaning they'll line up nicely, then definitely use a when, because it just looks clearer, and it will create the correct code underneath, like a nice efficient jump table for you, which is why you want to use a switch in the first place, right? A switch is more efficient because it's creating a jump table. A when clause will optimize under the covers and create a nice efficient chain for you. I should mention that there's no ternary operator in Kotlin, so that's where you would want to use an if statement, because it's just an if and an else. There's no ternary because if is an expression. So, think of it. That's a really good question, James, and we do go through that at work a lot. And some people, it really is kind of an opinion, but that's mine. Use when if it's more than one case.
Very good. Follow up from me on that one.
Sure.
Some Ruby that I've done. Does Kotlin have an until? Or an unless?
In what respect? Can you?
So an unless is basically the inverse of an if.
Oh.
Until. It's like a when.
No, not in the sense that you're talking about. But there is this thing called take if or take unless. So here's some object, take if this expression, or take unless this expression, and that's an extension function on everything. So yeah, there's no unless, and there's no in Perl, like or die or whatever, to get out of a method. There's nothing like that either.
Very good. Let's see, from Code Guru, what does the compiler do if you provide multiple classes in the list? And he might have to let us know where that was. That had something to do with, maybe it was going back to the when statement. I don't remember.
Oh, if you're matching when and you have more than one class. Let's do that in a second. I'd have to play with that. I think you can say is int or string. I think you can is int or is string. I think you can just do that, if that's what you mean. Oh, it says no. Daniel says in chat, he says no. He was talking about extending classes. Oh, if you're extending. So when I said when you create a class, thanks, Daniel. That there's just colon and then a list of things you're implementing or extending. Yeah, if you try to extend from more than one class, just like in Java, it'll error out. So if I say, my fancy class colon string comma list, or a string comma int, it'll fail. The compiler will fail you. Thank you. That's a good question, and thanks for the clarification. Can't hear you.
Right, my daughter just walked in, so I muted myself.
Welcome to working from home, everybody.
Yep.
I'm just trying to keep my dog out of the room.
Here we go. James Schmidt says, do you think some or all of the Kotlin features will show up in a future version of the Java language specification?
I think so. I think so. One of the things I like about modern Java is the 6-month release cycle. I'm really digging this. I really like the fact that I'm saying, yeah, this is in Java now. This is in Java now. I think it's really cool. But I like working in Java and I like working in Kotlin. And I think if they do, then that's great. There's more ideas in the ecosystem, and if Kotlin ideas flow back to Java, I think that's really, really cool. You already see some of it. You already see better switches. You already see some type inference for instance ofs coming in or came in Java 14. You see var, local var in Java 10. I think that's really cool. And this, the stuff that's coming for Java is actually really, really cool. The Loom stuff is really cool. Yeah, Jim says that Java's new switch is more Kotlin-like. Yeah, it is. It's really nice, and it's going to get better. There's more stuff coming for that. So yeah, I think a preponderance of what's in Kotlin is going to come to Java. I'd be really surprised if null safety, to the extent that it's in Kotlin, comes to Java, because it's just a very big change to the language, and probably extension functions. Records are there, but records are immutable. But that's a really, really great step. I mean, because a lot of stuff we do for DTOs and whatever, that's all just records now, right? From 14 on, you can just do records. I think that's really cool.
All right, very good. Next one, and looks like we've got someone just came in, so we've got 4 more questions.
Okay.
From Lee, type alias = C define.
God, it has been forever since I've written C code, but I think so. From what I remember about C define, those are macro, like compiler macros, right? They're just search and replace effectively. If a type alias is not anything different at runtime. If I create code with a type alias and without it, you wouldn't be able to tell the difference. So the bytecode would be precisely the same. The compiler doesn't do anything any different. So, so I think it is, but I'm sorry. It's been 30 years since I've written C code. So
no worries.
Sorry.
All right. From Bill Harton. Do you have a preference? Oh boy, a preferred IDE for Kotlin, JetBrains or Eclipse or?
My shirt is flame retardant, so we'll get this on. For Kotlin, I think it's pretty clear that JetBrains, IntelliJ is going to do the best job because they're writing the language. They're constantly updating the plugin to be better with the language. When you go get a new version of Kotlin, like yesterday, I think Kotlin 1.3.72 came out, and some of the fixes are the plugin that goes into IntelliJ are released with the language, right? So IntelliJ is going to have a leg up. I know a couple of coworkers who use Eclipse and use the Kotlin plugins for that. They complain a little bit, so your mileage there might vary. Plugins are available for other things like VS Code and Vim and whatnot. I'm an IntelliJ person, so that's what I use, and the support there is excellent. So if you can, I would use that one just because they're the ones who originated the language, so they're going to be first with new features and new shinies. But there are other solutions that do work.
Sure. For those that are interested, is Kotlin available in the community edition of JetBrains?
Yes, it is.
Okay. So
yes.
If you want to get started with Kotlin and don't want to shell out the money for the Ultimate, then you can use the community edition.
Yeah, you totally don't need Ultimate for anything that I've explained, or pretty much anything I've even alluded to with Kotlin. You don't need. I can't think of one Kotlin feature that you need Ultimate for.
Very good. All right, from Scott Hastings, can you elaborate on the paradigm for apply? I'm sure I'm missing something, but it just looked like a more verbose constructor. Thanks.
It is a more verbose constructor, so I can call the thing I didn't go into with apply is that I can kind of do anything in there in the context of that person object, right? So I can call functions, I can do anything. It's just a nice way to, instead of saying here's a person and now go do these things to it and then return the person, I can create, manipulate, and return the person in one step, and that's why you'd use apply. because it's not always convenient to have a temporary variable, things like that. I hope that helps.
Alrighty. I'm forced to homeschool my son. Should I introduce him to Kotlin first or Java?
Mike Finn. I know a guy named Mike Finn. I don't think he lives in Utah, but I wonder if it's the same one dialing in. Maybe the answer is neither. My daughter is home from college. She's it's the same Mike Finn. God, Mike Finn, how are you, my friend? Oh man.
Where are you calling in from, Mike?
Mike's in California, I think.
Oh, cool.
LA. Sweet, Mike. I hope you and your family are safe. Honestly, I'd give Python a look for first language for homeschooling. And I know that's like heretical for a Java user group to say, but Emma's home from college and she's taking computer science, which she's like really into. My daughter's like really into English and singing, and she's like the pretty good, is really good writer, really good singer, and she's taking computer science because it's all pass fail this term, and she's home with me so she can get some help. But she's learning Python, and it's actually she's like really picking up on the concepts and learning it. And we were looking, she's like, I like this class. I might take another computer science class. And we're looking at the next one, which is all in Java. And it's like way more complicated, just explaining the basics. If it's Java or Kotlin, I would do Java because I feel like that's just more useful. It's probably easier to teach Kotlin, but I feel like Java would be more useful. And, I'll stick to my neither is right. You should probably learn Python as the first language.
Fair enough. Alrighty. Last question so far from Moanj. Does IntelliJ add .kt extension if you have more than one class in the file?
Yeah. So if you're looking at the side view in IntelliJ, it'll just say, if you have one class in your file, if you have a class called, my special class, you'll just see my special class. But if you have my special class and you add another interface or a class or something, it'll say my special class .kt. And again, you can put whatever you want in a file. You don't have to limit yourself to one thing. I put for example, I put all of my DTOs for a set of controllers that are logically grouped. I put them in one file because they're all just data objects and they're one line each. I put all my exceptions for small Spring Boot projects in one file because, again, they're largely one-liners. I put the extension functions in one file because they're generally pretty small and they're standalone top-level functions. So, IntelliJ will do that. It'll show the .kt, which is the file extension for Kotlin files. But just in terms of organization, just do whatever makes you feel good. If you like them all separate, like in Java, then go for it. But people tend to group them, and I think that's one of those things that's like the community is still deciding like where's the right way to go with that. There's still not a lot of guidance. Like there's a style guide for Kotlin that the compiler will enforce, which I love, because I don't like the 50 different dueling styles that Java has. Just pick one. I don't care is my attitude. But I think this is like the little squishier. It's hard to tell like where to go with that. So I think we're as a community, we're still trying to figure out what the right thing to do is. So maybe in your organization, you're going to have to talk that through.
All right. Very good. So that looks like all the questions.
Sweet.
Before we get to the door prize drawing, which we will do next, I want everyone to know that this will be available for replay as well. So if there was something that you missed, or if you came in late and want to catch the beginning, or if you want to send your coworkers over and let them see this, they can get that as well. And that is the same URL as what the meeting is right now. So it's crowdcast.io/e/ujug-april-2020. And you can get to that from here.
And I was serious about the questions thing. If you get all my contact at the end, if you're working on something and you have a question, or if you're working on, if you show your coworkers and you want to ask questions or whatever, just reach out. I'm accessible and I'm happy to help answer questions or point you in the right direction.
Very good. All right, so I am going to mute both of our cameras real quick, and we'll do the door prize drawing. All righty, if I can get to the right tab. All right, so the door prizes we have 4 JetBrains licenses that are going out, and those are going to Mega Learning, S. Fesher, Scott Greenman, and Derek Hansen. If if you have something specific you want to use it for, let us know. But we've got your emails here. We should get those out to you within the next day. Congratulations on those. The Agile Learner is going out to Christian Purser. So that is a 1-year subscription to Venkat's Agile Learner website, where he's got a lot of his talks that he has given over the years available to you, that you can go see those as well. And we had a late one come in. So Kate from Tech Systems says that she is going to raffle off some cookies. So Mike Maservi, you should be able to get some cookies from Kate. We'll send your email over to her, and she'll work with you on getting the cookies out to you. So that should do it. Since this is the first time that we've done this, we'd like to know how it went for everyone. If you want to give us some feedback back at board@ujug.org, feel free to let us know. Also, let those that you know about UJug. Again, we're going to be doing this virtually for at least another couple of months. Hopefully by then, everything will calm down. We'll be able to get back to meeting locally. But we are going to look at doing these virtually as well after we're done with quarantine and whatnot. So we'll look at that. So once again, thank you everyone for attending. We appreciate you being here, and hope you all stay safe. Those of you that are in Utah, hope everything's been going well, that the ground shaking hasn't bothered you too much. Yeah, but it's all good. Again, thank you so much for attending, everyone, and we look forward to seeing you next month.
Thanks, everybody.